Hello all, welcome back to another video in the LLMs related playlist. In this video, we are going to see about an important aspect which is not usually talked about when we are talking about LLMs, which is evaluation of LLMs. Okay, because this is the aspect which is going to tell you about if your LLM is suiting for your use case. Okay, so you are building some LLMs which is of maybe 3 billion, 10 billion, whatever parameter it is, but you are aiming at a use case for it. You wouldn't know if it is working for your use case if you can't evaluate it. But why evaluation of LLM is a big topic to discuss that we are going to see in this video. So in this video, we are going to answer some critical questions as you can see here. Why to evaluate, where to evaluate, what to evaluate, and how to evaluate. Okay, these are the main questions to be answered when we are talking about evaluation of LLMs. Because when we are talking about evaluation of LLMs, we need to create a complete pipeline. Okay, it is not a small component calling it as model.eval or in Hugging Face calling it under a compute metric function. It is not going to happen. It is a large domain or discipline to be more precise. Okay, so without wasting some more time, we'll jump right into the video. Right? Okay, so as you can see, I've written an exhaustive blog or notes here. Okay, it is from different resources. I have seen different resources available in the internet, especially a paper known as Survey of Evaluation of Large Language Models. Okay, so here you can see I've already gone through this, and guys, see here, it is even in preprint stage. Okay, so this is one of the latest paper you can find for evaluation of LLMs. Like you can see here, it is 28th August. Okay, and today it is 2nd September while I'm recording it here. So it is one of the newest paper available, and trust me guys, it is an amazing paper, but it takes long time to go through this. And I've gone through this paper, and additionally I've taken some other resources as well, mainly focusing on this paper. I've created this content. Okay, so I'll leave the link of this paper also in the description. So if you are interested, check it out. And if you are wondering what is this website, guys, this is the website of our channel. And whatever document is there related to videos which are there in the channel, like Jupyter Notebook or slides, everything will be available in this website. So here you can see this is the introduction page, and if I'm having some playlist, the playlist will be here, and the links of the videos will be available here. And in every videos there will be a resources attached to it, and you can open it. Okay, so the most recent video was evaluation, and before that obviously I need to add code llama as well, because that has been uploaded by now. So that also will be uploaded, guys. The video link alone should be changed. So the code is here, the resources also here, and that will be uploaded here as well when you are seeing this video. Okay, and finally we have this evaluation of LLMs is all you need, and that is what we are gonna see now. So like I said, evaluation of LLM is a big facet to be understood when we are building an LLM pipeline. And there is this one person called Eugene Yan who has spoke about it in a very different way and in a different aspect. All right, like it is very refreshing. There is a blog from him, and I'll make a video on that as well very soon. Most probably the next video will be on his blog, which will say about how to build your own LLM pipeline. So coming on to this, we are explaining this critical queries. Why evaluate LLMs? So if you see, when we are coming into evaluation of LLMs, the most important point is why to evaluate. Because if you don't know why to evaluate, there is no purpose of doing evaluation, right? So evaluation is usually done to understand the strength and weakness of your model. Okay, so that is what why to evaluate is then. And obviously there are some other reasons as well, which I will be explaining in some time. Okay, I'm just giving an overall view. And coming on to what to evaluate, this will say like what are the facets you should be focusing on when you are evaluating the model. It's not just if you're having some task summarization, I can just evaluate summarization. No, it's not going to happen. There are some factors which is affecting your performance of summarization, which you should know. Let's say your model's bias or its coherence, its context handling power, or else capabilities. That all needs to be evaluated, and I'll be explaining every aspect of it in the what to evaluate section. And where to evaluate says where are the benchmarks which is available right now, and how to address what are the facets available there in what to evaluate, how to create benchmarks or else use the benchmarks available for the task. Okay, that is what we'll be doing in where to evaluate. So we'll be just finding benchmarks for what to evaluate. Okay, that is what where to evaluate is all about. So consider this. You know what are the tasks should be evaluated. You know what are the benchmarks you should use for that evaluation. Next one, it is to see how to evaluate it. Maybe it might be a metric driven, which is automated, okay, automated metric driven, or else even human can evaluate it, which is more preferable. Okay, so we'll be seeing about that as well in how to section. So that is what is there in this video. Like I said, this will be a complete A to Z guide, guys. It is a step by step A to Z guide for evaluation of LLM. Now, coming on to what is evaluation. Okay, so we are just jumping onto the video right now. What is evaluation? So evaluation is the process of analyzing the performance of the model with the help of some metrics. Okay, so there are metrics like ROG, F1 score, and many more. It is the process of analyzing the performance of the model, basically. And this will involve assessing the factors like language fluency, coherence, contextual understanding, factual accuracy, and many more. Okay, so because if you can't generate a coherent text in a fluent manner, there is no point in creating a language model which will generate some content, right? So it will involve some factors like that, but there are many other factors, and these are some of the factors which is very crucial. Okay, but now coming on to another question, which is what is a good evaluation? So see, there are a lot of ways to create your evaluation, but for a evaluation pipeline or an evaluation, how can we term that it is a good evaluation? First, your evaluation metrics should be correlated with your outcomes. So if you are using some simple language models, small language models, and you are doing some simple tasks, you can go with some simple metrics. But with the increase in complexity of the task and increase in the complexity of the models, you should obviously go for some appropriate metrics. So that's what it states. And if you don't understand what this point is, when we are answering this question, why this conventional methods of evaluation doesn't work for LLM, you will understand what is correlated with outcomes is. And coming on to the next point, which is very less number of metrics. In an ideal world, it should be single metric. See, there are a lot of tasks. Like I said, here also you can see there are a lot of tasks which is given there in this what to evaluate section. And we'll be evaluating on every aspect. But we can't keep track of every metric, right? So it should be easy to track and monitor. So that's what very less number of metrics states. Okay. Then finally, it should be fast and easy to compute. Okay. It should be automatic as well, because you can't evaluate in every step, right? You can't just always evaluate it by yourself. It should be as automated as possible, but there will be some human intervention which is needed. Okay. So that is how a good evaluation should be. Now, coming on to the next question, you might think, Vasan, there are some other metrics like accuracy, F1 score, which is there right now. Why we should discuss in detail about evaluation methods for LLMs? See, the data used while training and the data which you will face in the production will not be the same. Mostly it will not be the same. Okay. So you might train for a different way of data, which will be mostly open source, and the data you will be facing will be slightly different with the end user. Okay. So that is one of the crucial problems. And another one is with the LLMs, you won't have a definitive result. See, for example, here we can see in traditional ML, we are considering scenario of sentiment analysis. Okay. So in PRED, what it does is the original prediction which the model gave was positive, negative, positive, positive, and the label was positive, negative, positive, negative. So you can easily say, okay, there is only one specific instance was wrong. So the accuracy is 75%. So that can be seen here. That is fine. Okay. So in this use case, it is fine. But with LLMs, the generation behavior is very complex. You can't understand, like, it will be generating like this. You can't just previously say the next token which is going to be generated from the model will be is or whatever word it is going to be. Okay. So here, let's consider another example from LLMs where we are considering a summarization use case of a context given. I'm not giving the context here. This is some sample which I have written by myself. So prediction was, which is from the model. Usually LLMs works very well with a wide variety of NLP tasks because they are great generalists by the nature. Okay. So it says that LLMs work with wide variety of NLP tasks because usually they are generalists. Like, they can generalize their knowledge and it will work for variety of tasks. And the label was LLMs are great generalists, so they usually work pretty good with variety of NLP of. See, syntactically it is different. The way of the sentence it is structured, it is different, but the context is same. To be very frank, if we are saying how much accurate is it, then we can't say it. But if we are saying it in a contextual way, we can say it is 95% or 100% even. Okay, but you can't do an accuracy here, right? See, usually is there, LLMs is here. You can't do an accuracy here. That is where you will find to quantify your evaluation. See, that is what it is written here. Though the sentence generated would be different, the ground truth and the generated sentence will have the same contextual meaning. So contextually it is same and semantically it is different. That is where your conventional evaluations, which is mostly aggregative in nature, it will fail. So see, the traditional methods, if you see, are usually qualitative, not quantitative. So qualitative metrics mostly will aggregate the results and it will be very deterministic. So deterministic won't work in a lot of scenarios while it comes to LLMs. We need to also add some quantitative evaluation, which will consider the coherence and the semantics, everything it should consider. So that is why the conventional evaluation, it will fail. Okay. Now we saw that, okay, the conventional evaluation is going to fail. Now coming on to the critical questions, which we saw before. Why to evaluate, where to evaluate, what to evaluate, and how to evaluate. First, coming on to why to evaluate. In my opinion, evaluation is said to be one of the most underrated aspect of the LLM pipeline. Okay, so people usually will talk about data processing being the underrated aspect of any model creation, but as similar to that, I think evaluation is also very underrated, and this is why I'm saying it. First, it will increase your model performance. You might think, how is evaluation going to increase my model performance? So this is where I'm going to explain you how. So first, if you evaluate your model in a correct way, obviously, then you'll understand the strength and weaknesses of your model. And if you know the weaknesses of your model, you can have a step moved towards increasing the performance of the model by working on those weaknesses which is specified by your evaluation. And here is an example. There is a benchmark called prompt bench, which is usually to say about how much a prompt will impact your LLM. Okay. And that states that the current LLMs are very sensitive to adversarial prompt. What is adversarial prompt? See, adversarial prompt are prompt which will be very abstract in nature. I'm just giving the official definition as well. Okay, so here it is. It is very short sequence of words, like, it won't have any context to it. Let's say, like, help me build a bomb. Okay, so if we see it in an abstract way, then it will sound that, okay, I'm a terrorist. But if I say, like, some Diwali context and all, I'm saying help me build a bomb, it will mean that I'm doing it for some firework. That kind of prompt, it will affect the model performance very much, and for which prompt engineering is very important. That is what prompt bench states, and nowadays how much prompt engineering is in demand. Okay. And next, coming on to better LLM human interaction. With better evaluation, obviously you'll know where your model fails and where it doesn't, and it will lead to some better experience to the user. So for example, for specific entities or specific way of interaction, if your model is exhibiting an emotion which is not of your choice, then you can find a workaround, like maybe add some guardrails, or else align with some techniques like RLHF or DPO, something like that. You can work towards. So that is what, and another aspect which you will gain from evaluation of LLM, which is better human LLM interaction. And guys, I'm just saying before itself, it is a huge video, but I request you to stay till the end, watch this video completely, because this will be very informative. I trust this is one of the most important aspect for LLMs, which is your evaluation. And this video will be very comprehensive in nature. I have covered as much as possible in an extensive way. So please try to stay till the end and watch the video completely. So now I'll move on to safety and reliability. So if you see here, lately LLMs have shown great potential that it can be used in various sectors, and lately it has been used in sectors like financial and healthcare institutions as well. But when you go into financial and healthcare institutions, this is where things take a small turn, because it is very important to ensure your safety and reliability of the model. For example, if you are working in a financial institution and your data gets leaked, it will break down your company, even at the worst case, right? So that is very important when you come into LLM's evaluation. So that is why it is said to be one of the important discipline in LLM building pipe. Okay, I hope you guys understood why I said it is one of the most underrated aspect. Now we'll move on to what to evaluate. Coming on to what to evaluate, if you see, once we find the answer for this question, which is what to evaluate, we'll claim the strength and weaknesses of the LLM. Okay, that is the motto of this question. Okay, so usually the tasks to which the model should answer, it is under these broad categories: natural language processing, robustness, ethics, bias and trustworthiness, social science, STEM, and application. Okay, and you need to worry about, okay, these much are there. I'll explain all of those. Okay, natural language processing tasks. The main objective behind LLMs, which has been, is to improve the performance in NLP tasks, right? Like, be it understanding or generation. As the name suggests itself, from the definition, whatever it is, there are two parts involved, which is understanding and generation. And we'll see that in that way right now. Okay. Natural language understanding. Whichever task will involve you to have a better understanding of the input. I term model here. If the model needs to have a better understanding of the input, it all comes under the umbrella of NLU. Okay. So how this what question or else this what evaluate section would be structured is, I'll say about what is the task, how the model has performed, and is there an improvement, and in my opinion I'll say how it can be improved if it is possible. Okay, and now we'll jump on to the first task, which is sentiment analysis, and it will involve analyzing and interpreting what is the emotion that is there in the text. So usually it would be binary or triple, which is positive negative or positive negative and neutral, and it is said that LLMs have shown a great performance overall, but with low resource language it wasn't able to perform as expected, which is subpar performance. Okay, see, low resource language, what are the low resource language? Like Indic languages can be said as low resource language. Possibly not Tamil, not Hindi. I've seen a lot of resources for Hindi, but still comparatively it is also a low resource language. But Dravidian language, surely it is a low resource language. Okay, and there are some other languages as well. Overall in the world, there have been a lot of language which has very low resources, especially non-Latin languages. Okay, to improve this, obviously, as the weakness suggests, you should have some more data being collected for low resource language. And coming on to text classification, it is similar to sentiment analysis, but it won't just focus on the sentiment, but it will focus on all the aspects of the text. Okay, but like in the sentiment analysis, here also it has shown some great performance, but it should work pretty much very well with low resource languages as well. Coming on to some next interesting tasks. First one is natural language inference. See, natural language inference, if you don't know what it is, you'll have a premise, which is your context. Okay, and you can give a hypothesis. Let's say I'll walk 6 a.m. in the morning, which is the context, and hypothesis. I'll add a word usually. Usually, Vasant likes to walk in 6 a.m. in the morning, and the hypothesis is Vasant likes to walk when the sun rises early. Okay, during the sunrise or something like that. I hope you got the context. And if you see, yeah, it is correct, right? Like, usually in the 6 a.m. of the morning, the sun will start to rise, and that is the time when Vasant likes to walk. And the task here is to determine whether the hypothesis is logically following the context. And here it is following. Okay, so it should try to say, okay, it is a contradiction, or else it is not a contradiction, something like that. Okay, not a contradiction is known as entailment here. Okay, so it is a big task. Okay, natural language inference is one of the biggest tasks in NLP, because mostly LLMs have poorly failed in this NLI task, and there are large improvements which is required in this field. But what happened was, let's say ChatGPT, for an example, has been pretty good with outperforming others in handling this kind of factual input, and it is said that it is possible due to the RLHF training process. So I guess you all might know RLHF by now. And if you are wondering, okay, Vasant, how to do RLHF? We haven't made a video of RLHF yet, but there is an alternative for RLHF which is being on trend right now, which is about direct preference optimization, which is said to be an alternative for RLHF that can also align the model's responses to human preferences. Basically, it is just forcing the model to generate in a way you want. Okay, so that is how it is at least hypothesized to say that ChatGPT has performed very well than the others. Okay, and like I said, the solution is also here. Maybe train your model with optimization techniques like RLHF, DPO, and all. Okay, next, coming on to semantic understanding. So if you see NLI, semantic understanding, and the next task which we will discuss, which is reasoning, all comes under a similar thing where you will need to have an in-depth understanding of the language and the concepts associated in it. Be it comprehension of the words, phrases, sentences, and understanding the relationship between the sentences. Okay, so it will not be at the surface level, it will go deep so that you will understand the meaning of the sentence and the intent which is there in the sentence. And if you see, with individual events, the LLM has possessed great understanding and it has given some great performance. But when you have some basic phrases like, very simple phrases with no context and all, or with have some multiple events, then LLMs has usually failed, and that is one aspect again for some great improvement. Okay, so that is there. So if you are working on a model, you should very much have in your back of the mind that your model should very well work with semantic understanding. Okay, and next, coming on to reasoning. It will also involve semantic understanding, which is, again, we have said that it is a significant challenge, right? But though it is already a challenge. Why reasoning is more challenging is that you should not just understand the semantics of the context which is given, but you should also understand the provided information and make some reasoning out of it. Okay, so let's say I have some three apples, my father gave three and I ate one. Okay, this is a context. I should understand that, okay, I have some three apples, my father gave three, which is 3 plus 3, which is equal to 6, and I ate 1, which is 3 plus 3 is equal to 6, minus 1, which is equal to 5. So it is a step by step reasoning one, right? First, I should understand the context, because here the context is how many apples are there. That is the context here. To understand that, I'll take, okay, 3 apples plus 3 apples minus 1 apple. Or this is where the reasoning come into picture, which is coming under mathematical reasoning here. But similarly, there are some other reasoning like common sense reasoning, logical, and domain specific reasoning. Overall, if you see, mathematical reasoning has been pretty good, okay, but with complexity being increased, the performance has been very poor, both in mathematical and logical reasoning. Okay, so if you give some arithmetic task, it will do well. If you give some maybe kind of prime number or GCD, simple task like that, the model will do well. Okay, but if you go some complex task like polynomial handling, which is algebra, as well as task like trigonometry or else calculus, it won't do well. Okay, so that is there. And logical reasoning with the complexity increasing means there will be a lot of logic involved. Like, it won't be in a single step. It will involve multiple steps, and that, I guess, it is pretty obvious, because even we won't work or give some output very well when there is a lot of logic involved. Okay, and if you see, model has given a pretty good response with common sense reasoning, but when it comes to domain specific reasoning, there are lots of room for improvement. If you give some medical questions or else even law questions which require some reasoning in that, the model has failed. Okay, so that is what domain specific reasoning is. So generally, if you say reasoning capabilities is again a challenge for the model. Basically, if you see, if there is a need for in-depth understanding of the context, the model is failing. That is what we are understanding here in reasoning, semantic understanding, and natural language inference questions. Okay, guys, now itself see how much informative it is. So we usually see, okay, it is failing in this task, I'll increase the data in that specific task. And we won't focus on these kind of tasks, right? Like reasoning or NLI or semantic understanding. We just focus on tasks which is our end task, like maybe summarization, translation, anything like that. But these are the things which is going to be your base, right? Like if you don't understand the context very well, you can summarize it. So that is pretty obvious, right? So yeah, it is very important to understand all these tasks. And like I said, in where to evaluate section, I'll say how to find benchmarks, or what are the benchmarks which are available for each of these tasks. Mostly for every task, there is a benchmark. Okay, now coming on to natural language generation. Guys, now understand. When an LLM is there, it will understand the context and it will generate the context. So here, if we have saw, okay, these are the way, these are the tasks we should see about when it comes to understanding the context. But when coming on to the generation, so here are the tasks. First, we are having summarization, which is obviously a popular task which aims at learning a concise abstract from the given context and generating it in a coherent way. When you have some controlled text summarization, if you see, the LLMs have been more extractive than human summaries, which is not preferable. Okay, extractive, if you don't understand what is extractive, it will just take the sentences which is there in the context itself. It will just take it and it will return it, which is not preferable. Okay, you need to understand the whole context, and we expect the model to generate the context by itself. So it is known as abstractive summarization. And when you have a controlled environment for text summarization, it has been extractive. And on an overall scenario itself, when it comes to summarization, there is room for improvement. Okay, it has been okay or else satisfactory, but still there are room for improvement. And coming on to the next part, which is dialogue. See, it is one of the most important tasks when you are creating a system, because see, when you're creating an LLM, there are two ways where you can interact with your LLM, or there are two interfaces in which you can interact with the LLM. One is going in a chatbot way, which is your dialogue, and then another one is question answering, which we'll discuss again in the next second title. Yes, so it is very important for your model to have some good conversational capabilities, and don't you worry, guys. The model has given some pretty good results, usually with conversational tasks, but it has posed some challenges as well. When you have some long-term multi-turn conversational, like say, you have made some 10 conversations and you are expecting a model to return some answer based on a question which will require some contextual understanding of your first chat. I hope I make sense. You're saying like, who is the president of America, and it is written Joe Biden. And you're having some 10 conversation. After that you're asking something related to Joe Biden. Okay, so the president, what he is up to right now, maybe some trending news you're asking it. Okay, then it should understand first that you have asked about the American president, who it is about. It is Joe Biden. Okay, so it should understand that, okay, I need to say about what is Joe Biden doing. Okay, that requires a lot of contextual understanding. Okay, it depends a lot, because it should have a remembrance of all the conversation you made. So that has been a challenge right now, and hallucination is also there. So these are some challenges posed by the LLM. Okay, now coming on to translation, it is said that LLMs are not explicitly trained for translation, but if you see, it has been performing very good with translation tasks. But it is only when you are having a scenario like X to English. X means some language. Okay, with English being the target language, it has been pretty good. But with English as source language and X as target language, it has not performed very well. And with low resource language, it has been very well. How is this? After I think about it for some time, and I found the answer for it, why it is like this. See, even if we are there, and for example, I can understand Hindi, okay? And if I'm watching a Hindi movie or Hindi commentary in some cricket, I can understand what they're saying, but I can't talk, obviously. But I can get, okay, this is what they are trying to say about it. So if you see, I'm just translating the context or any other language for the matter for you. Okay, but if you ask me to say something in Hindi, I'll be struggling in it, right? So similarly happens with translation with LLMs also. So anything to English is not very hard for the model, but when you ask something for it to generate from English to other language, then it will fail. Okay, I hope so. I make some sense in translation. And question answering, if you see, it is, like I said, it is one of the interface for human LLM interaction, and it has been used for various scenarios like search engine, customer service, QA systems, and many more. Okay, and if you see, LLMs have usually performed very flawless. Okay, nearly flawless. It has been pretty good. But if you see, if you're asking, okay, Vasant, is there a potential improvement? Yes. When you're coming into some social events or common sense knowledge, it has required some improvements. Okay, possibly it might be due to its cautious nature, because if you see, let's say for example, ChatGPT or else the recent released model like Llama 2, if you ask something which is social in nature, it will try to avoid the sentence, like it will say like, as an AI language model I can't talk about it or something like that. So it should try to understand, okay, it is not very harmful, the content is not harmful, and it should generate content accordingly. So that is a potential improvement. Okay, and coming on to open-ended generation tasks. See, there are other generation tasks other than what we have talked about right now, and some of the tasks is like, writing generally. There are tasks like, sentence style transfer, writing tasks like informative, professional, creative writing, many more. So you can write an email, right? You can write blog. Obviously, if you see in this blog itself, what I have written right now in the website, I could have used ChatGPT, but I prefer not to. But still, you can write some content. If you say like, tell me about global warming, and it will write a detailed information. And coming on to professional writing, you can say like, write an email and it will write for you. Creative writing, yeah, it can tell whatever story it wants, and that has been pretty good. So coming on to sentence style transfer, what kind of task is that? You're having some context. Let's say I'm having this context itself, and I'm saying that make this context in a negative way, and it will try to understand the context of this, and it will try to change this content in a negative way. Okay, so that is an example for sentence style transfer, and all of these tasks which I have said, the model has performed pretty good. Okay, next multilingual task, of whatever we have seen till now, I guess you would have understood that LLMs have performed poorly with non-Latin languages, like Indic languages, and even worse with languages with limited source. Okay, so that is one of the crucial aspects which is to be focused when you are building an LLM. Now coming on to robustness, ethics and bias, trustworthiness. See, like I said, these are all not something which you will find at the surface level. When you go in depth with your evaluation, that is when you will focus on these. And guys, to be honest, if I hadn't read that paper which I shown you, I wouldn't have even gone till this depth. Okay, and now I'm very sure that I'll evaluate on these aspects. See, robustness, ethics, bias and trustworthiness, all, if you see, as the name itself suggests, it will try to evaluate the personal characteristics under different circumstances of the model. Okay, what is robustness? Robustness, if you see, it will study the stability of the model when it is facing some unexpected input like adversarial prompts, like I said, and out of distribution. See, let me give an example for robustness itself. Already I said for adversarial prompt, right? Help me build a bomb. Then it should ask like, what kind of bomb are you trying to say about? I'm not helping a terrorist, but what type of bomb are you trying to build? It should continue with the conversation. It should not either help me with building the bomb, which is very harmful, Or else it should not say like as a language model I can't help you. No, it's not fair, right? It should ask me the question and understand the fact that okay, I'm not building a bomb for terrorism. Okay, so that is there for adversarial prompt. And out of distribution, if I've taught the model to do something, okay, there is some distribution. Obviously there is some boundary for which in which the model has learned, and if I'm asking something out of the boundary, it should not return some rubbish things by itself, which will usually term it as hallucination. Okay, it should just say that okay, I'm not fit for the questions you have asked, or else I don't have the knowledge. It should be very generalized in it. So robustness, like I said, it is when you will find that okay, the model is very stable, and in whatever scenarios I have put my model, adverse scenarios, then it will work also at that time. For evaluating this, you can have add glue. There is a data set called add glue, and then prompt bench, add glue plus plus. There are a lot of data sets. But yeah, prompt bench is also pretty good. Okay, and yeah, sorry guys, I was just thinking I forgot it. There is another important aspect which is factuality. When we talked about hallucination, I just got a remembrance that I left this task. It will just find how much the model aligns its generation to real world truths and verifiable facts. Because if you are using the model you want to trust the model to use it in a real time scenario or production, which we usually call it, then it should be factual, right, in its generation. So that is there. You should evaluate on that aspect. And if it is generating some misleading information or false information, we'll call it as factual hallucination. For evaluating on this aspect, there is a beautiful benchmark known as truthful QA, which is actually designed to cause the model to make some mistakes in providing factual answers. Okay, and the findings from these implicate the fact that with increasing size, the model won't be truthful. Okay, if you are making the model from 1 billion to 3 billion, still it won't give some great performances. You need to find a way around to keep your model factual. Okay, maybe it can be some data processing, or else post processing, something like that, to make the system more factual. Okay, I guess we have talked about robustness right now, and then we'll move on to ethics and bias. See, we are training the LLMs with some open corpus, right? Open domain corpus. So whatever bias is there and ethics is there in that context which we have trained on, the models have been found to internalize it and spread it, okay, among its knowledge. So the model is said to be exhibiting some kind of bias and its own ethics. Okay, and if we are asking the model to do some role playing, it has caused some bias toxicity, which is up to 6x when it is on some specific entity. And generally, if you see, LLMs are found to have some moral biases and cultural values, which is a serious risk when we do some deployment, right? It can be very harsh because I don't need to explain about moral biases and cultural values. It can take a bad turn when you are having it in production. So it is an important aspect to evaluate when your model is going into production. Next, coming on to trustworthiness. If you want to say that your model is trustworthy, you need to evaluate on all these aspects. Toxicity, stereotype bias. I think you all know stereotype bias, right? It should not be judgmental directly. Let's say if I am saying about something where usually there is a stereotyping in the world, it should understand that okay, I should not be stereotype, and this is not the truth. I'll not be stereotype here. And then we have adversarial robustness. I think we have talked about this a lot of times right now. Okay, so, yep, that is there. Just give me a minute. Yep. So next we have OOD robustness, adversarial demonstration robustness. It should maintain the privacy. Obviously, there should be some ethics while it is generating, and it should be fair. So like I think all the scenarios, if we cover this, then yeah, the model should be trustworthy, because knowledge, yeah, it will gain from whatever context we have trained it on. But if we don't have these characteristics ticked against the model, then there is no knowledge. There is no point of having good knowledge, right? So that is there. So to have the model being trustworthy, these are all the aspects in which the model should be evaluated. Okay, and for this there is a dataset called Trust GPT. It's okay. Next, coming on to social science, it should be socially enough, right? Like socially enough knowledge it should be there so that it can solve some social problems, and it can apply the knowledge it has for some social problems if we talk to it. And it is found to increase the productivity of the persons who are working on this kind of aspect, like law or political science or economics and all. Okay, I'm just giving a brief idea on social. Next, coming on to another important aspect, which is STEM knowledge. I think you would have all heard about it a lot right now, which is science, technology, engineering, and math. Now, coming on to mathematics, if you see, I think I've given a brief introduction already. It has given very good performance with arithmetic task, but with tasks like trigonometry or logarithmic, it has been subpar. But it has handle very well with handling fractions, decimal numbers, negative, irrational numbers, and all. But when you have some complex equations or complex problems, the model hasn't performed well. Like I said, in polynomial handling or calculus, it does not perform pretty well. So you can see, like, LLM's effectiveness is highly influenced by the complexity of the problem that you can understand by the context which is provided here. Next, coming on to science, it has provided some commendable performance with biology and general science related tasks as well. It has performed pretty well, but it is said that it needs improvement with chemistry. Sorry for the spelling mistakes, guys. And physics also, it required some important knowledge, but improvement in the knowledge. But if you see, it is more needed when it is coming on to physics, because it has performed very worse in physics rather than in chemistry. So thus it is needing an improvement here. But if you see in a theoretical way why chemistry is performing at least better than physics, in chemistry why it is performing. In chemistry, the logic needed is not as complex as physics. Like, in physics there will be multi-step reasoning. You should understand each step and you should derive one after another. But in chemistry, it won't be that complex, and that is why if you see the semantics to be understood with physics also, it is very hard, and that is why chemistry has been slightly easier for the model rather than in physics. And coming on to engineering, if you see in the order of the difficulty of tasks, it can be ordered as code generation is beginner, software engineering is intermediate, and common sense planning is very hard. And with code generation and software engineering, the model has outperformed any state of the art model which is there right now. LLMs has outperformed any state of the art model. You can think, okay, LLMs are the state of the art model right now, right? Yes, that is true. But here, SOTA, which is state of the art, represents the state of the art model, which is for code generation. And you can again ask, it is code law, and you have made a video on that, and I've watched it. It is fine. It is the state of the art model, right? Yes, it is a state of the art model right now. But here, it means that you have specifically fine-tuned a model for coding. Okay, that was a pre-trained model. You have just used it. But here, the output of this model, like let's say if you have a GPT model and you are fine-tuning it for some code generation, and consider that it is the state of the art. And these LLMs, by default, with zero shot, sorry for the Tamil word, guys, which means that if you are having an LLM, I'm saying about zero shot, okay, you won't give any knowledge about the code generation task which you are expecting to generate. Okay, let's say if it is Python or Java. In Python, let me say, like, I'll expect the model to generate some code with the given function name itself, or generate a code with some given doc string, and many other tasks. Okay, everything will be there. This is what zero shot generation is. It won't have a prior knowledge that I'm expecting this from the model. Okay, without any label, it will try to generate it. And even with that, it has outperformed the state of the art models right now, which is fine-tuned for code generation itself. And even it is said that it has outperform human outputs at a lot of scenarios, but when it comes to common sense planning, it has failed because it is very highly complex to make some planning. Let's say if you want to build an LLM itself, you can't build an LLM with an LLM, right? It won't give the correct pathway. So that is what is said as another problem with LLMs. Okay, so you should maybe not use LLMs directly instead of a human. You can help it, you can use it as an aid for humans usually. So that is what this engineering aspect say. And before going on to application, guys, I would like to ask you all to like this video, because if you see, it has been a huge video, guys, till now itself, and I guess it will take another maybe 20 to 25 minutes to end this video itself. So you can see there are a lot of content there, and it has took me a lot of time to create this content, guys. So this is one of an unique video which you will be able to find right now. And if you like this kind of video, please hit the like button, and it will motivate me to make more such videos. And thanks to you all. I hope you all like the video right now. And another request is share it among with your friends and communities, so that they will also know that, okay, there is this evaluation which is very important, and I've not considered it right now, and hereafter I'll consider. Okay, so that is another request. And followed by that, yes, if you have any doubts or else any video suggestions, let me know in the comment section. Okay, now let me move on with the application. And here, if you see, there is one thing called agent application. See here, what is this agent application is lately, if you see, LLMs has been equipped with tools. Okay, so if you see ChatGPT and all, it has it's around 200 or 300, I don't know the exact count. It has the ability to connect with that much APIs to do whatever task you want. Okay, so it can automatically reply to your email. How it will happen? Because it has an API which will connect to your mail. Okay, basically whenever an input mail comes, it will try to respond to that email. So that is basically agent application. And there are some frameworks like Calm, Cosmos One, Tool LLM. Tool LLM, if you see, it is equipping the LLMs with tool and using capabilities. Cosmos One understands general pattern. Again, Tom is for utilization of tool, and Tool Former is to make a framework which will make the LLMs use specific APIs for specific tasks. And there are some others as well. Okay, but guys, if you see, you might think, okay, Vasant, I've not heard about till now. Yes, this has been a budding sector right now. Like, people are working towards it right now in open source. Obviously, like I said, ChatGPT has it. And there is this interesting one from Hugging Face itself. There is one thing called text environment. So, yep, I'm opening it right now. Okay, it is not opening. Just give me a minute. So here you can see this is what is tool tool actually. Text environment is the tool here. So if you see, when you ask a query, it will go to the model and it will generate a call basically to the tool, and the response will be given to the model, and finally the final answer is given. Okay, that's how it happens. For example, when you ask the question as in which country Oberhofen situated, the answer is Austria, which you have given, sorry, which the model has given. Okay, but when you go through this pipeline, right, like text environment pipeline, it will make a request to whatever tool which is able to find that, okay, this is the geological location of Oberhofen. Finally, it was able to find that, okay, it is in Switzerland, and it will answer, okay, it's Switzerland, not Austria. Okay, which defaultly say that if your model is not able to do a complex task, you can create a tool and it will do your work. Okay, it will do your work with pretty good result. So here if you see, Tim has $400 received, 1021. How much does he have? So here if you see, it is requesting to a Python interpreter, and it is providing some request to this solution, which is a tool. Okay, and so here you can see initial money is 400, money received is 1021. These are all the request which is created by the model to the tool. Okay, basically, and when you send this request to the tool, which is Python interpreter here, this kind of code will execute and it will return as 142. You can ask, Vasant, this is simple task. Yes, adding 1021 and 400 is not a complex task for the model, but when it goes to some complex task for creating such equations, okay, let's say like I have some 5 to 6 additions followed by some 2 multiplications, 2 divisions, 1 subtraction, this kind of interpreter will work very well. Okay, so this is another important. I'll make a video very soon. Please keep your subscribe button being subscribed and notification being enabled, because whenever I post a video, you will get the notification. All right. So that is about agent application, because it's not that there is only big models which can do agent application nowadays. Even with Llama 7 billion, we can do this agent application. Okay. Now, next, coming on to search and recommendation. This is another aspect, because basically, if you see, people are using ChatGPT for search engine rather than Google right now. I'm not saying it is a study which has said that people find ChatGPT more comfortable than Google search because it is very less time consuming. Not even half the time they have spent in Google search. Okay, and generally, if you see, no wonder, no surprise, LLMs have outperformed any models or any frameworks for information retrieval right now. For recommendation system also, it has been pretty good for because it has a lot of capabilities, like understanding the context, generating the context. We have seen some challenges, but it has been pretty good. Okay, so it is able to comprehensively understand the preferences of the user, what is the item there, and the contextual information of the item, and based on these, it will try to recommend, okay, man, you will find this item pretty impressive for you and it might be useful. That is there for LLMs. But the problem was there has been some scenarios where ChatGPT has provided some unfair recommendations. So it is very important to evaluate the fairness in recommendation. So if you are using a model, then be sure that your recommendation capabilities of the model is evaluated. Okay, so personality testing. So it will just evaluate the personality traits of the model, like how much evaluation it's showing. Basically, if you see, it has shown that LLMs perform as much like as humanly as possible, but the main limitation was it wasn't able to understand or generate humor in the contents. Okay, basically it is getting offended if we are being sarcastic and humorous now, like humanly, if we are going to say, it is being offended. So coming out of specific applications, if we are going to specific applications like log parsing, game designing, it has shown some potential that it can do, but it has some limitations as well, which says that it has broad applicability, but you can't just have it to every task which is there in the world right now. Everything has its own implications. So there is some potential to improve with specific applications. Guys, it has been so exhaustive, right? These are all the tasks which is needed for you guys to evaluate on. Obviously, in application section, it might not be needed for everyone, or else social science section maybe not needed. But every other task, I think everyone who is building LLMs should evaluate on that aspect. Now we all know, okay, what are the things we need to evaluate right now. So now let's move on to where to evaluate. Okay, so here we know the facets in which the model needs to be evaluated. Now let's find which are the benchmarks in which the model should be evaluated. First, we have Chatbot Arena. So Chatbot Arena, if you see, it is a platform which will compare diverse chatbot models. What it does is it will have some questions, and it will generate some responses. And anonymous users, which means the users won't know what is the model, and the users also is not shown who are the users. Okay, and they will vote that I prefer this response, or let's say I model A, B, C, D. I've preferred the model D response first, then B, and then C, then A. So basically, it is ranking the responses. And Chatbot Arena has been a pretty good benchmark when you want to know about your strength and weaknesses of your chatbot models. So guys, for an example, I'm opening this link. So for this alone, I'll open, but with all the evaluation, if I open, the time won't be enough. Already, I think we are close to an hour. I'm trying to be as fast as possible, but there are a lot of contents to discuss. Okay, so here, if you see, you can provide your model here, model B here, and then it will generate the content, and accordingly you can say A is better or B is better, or you can give tie, both are okay, and then also you can give both are bad, that is also there. Okay, so this is how Chatbot Arena works, and there are a lot of other benchmarks which we'll discuss. But what we can do is, like, you can try to open the links and try to evaluate it. But if you find it very difficult, maybe let me know in the comment section. I'll make a separate video on how to use these benchmarks. Okay, so I mean, like, basically how to incorporate these benchmarks in the pipe. Okay, so yeah guys, here we have our next benchmark, which is empty bench. So before moving on to the benchmark empty bench, I would like to tell you all that there is a surprise announcement in this video. So if you want to know what is that announcement, please stay till the end, and I'll tell about the surprise announcement. Okay, so that will be pretty awesome, I guess. So here we have empty bench, which is another benchmark to evaluate the conversational capability similar to Chatbot Arena, and both are coming on from an organization called LLMs. Okay, those are the guys who created the model, Vicuna. And here, if you see, what it does is it will evaluate the model's performance by using multi-turn dialogue and questions based on that multi-turn dialogue. So guys, if you see, we have talked about this in dialogue itself, right? So it was not able to handle multi-turn dialogue. If you ask some questions based on that, and requiring some contextual dependency, which is from multi-turns, it has failed, right? So in that aspect, if you see, empty bench is one of the greatest benchmark, which you can use it for evaluating your model, right? So again, if you see, like I said, you can click this link and find the benchmark. So next we have Helm, which is from Stanford, holistic evaluation of large language models. And as the name suggests, it is a comprehensive evaluation benchmark. Holistically, it will evaluate on different scenarios. There are 42 scenarios, and they have used 59 metrics. Okay, some of the scenarios are QA, IR, summarization, reasoning, coherence, and whatever tasks we have spoke about in NLP, all the tasks should be there in this Helm. Okay, and they have used different metrics for that specific task. So if you are going on for an automated evaluation method, then Helm should be in your books. Okay, for evaluation, Helm you should consider, and that is from Stanford. So yeah, that is there. Next we have Big Bench. So Big Bench, if you see, it is a famous benchmark going on right now, and there are 204 challenging tasks which is there with that are curated from 450 authors. Okay, so this is for reasoning. Okay, so again guys, I guess this is another benchmark we should note, because NLP tasks are then done, because you can use a Helm to do NLP tasks. But for reasoning, which is a main aspect in which the model has failed usually, you can consider this benchmark, Big Bench. And there is Scholar as well, which will require in-depth understanding. Okay, so these two tasks are pretty good. And next, if you see, we have Dynabench, which is dynamic benchmarking, and it is one of the robust mechanisms for evaluation, because it will involve human in the loop for measuring the progress in an accurate manner. Okay, and it is a crowdsourced mechanism which will involve not one person, it will involve more than one person, basically a crowd one. Okay, so there is bench if you are going for a dynamic benchmarking method. So next we have MMLU, which will evaluate our model on STEM, humanities, social science, and many more domains. So guys, let me just make a jot down of points here. See here, NLP tasks involve sentiment analysis, text classification, analyze, semantic understanding, reasoning, summarization, dialogue, translation, QA, open-ended generation, factuality, robustness, ethics, bias, trustworthiness, social science, STEM, application, right? So these are the tasks we have. For sentiment analysis, text classification, summarization, dialogue, translation, QA, open-ended generation, multilingual, and all. For everything, I think you should be able to find the benchmarks in Helm itself. Okay. And for robustness, ethics and bias, trustworthiness, factuality, I guess I've told the dataset in what to evaluate itself. For factuality, you can use truthful QA, and for trustworthiness, trust TPT. Robustness, we have adglue, and what was that another one, from bench, if I'm not wrong. And yeah, so I guess for those aspects I've already told. Next we have STEM and social science, and for domain specific tasks you have MMLU, because it will have a lot of tasks, guys. Trust me, it is a very comprehensive one as well. Maybe yeah, if you're having some specific domain evaluation, then you can consider MMLU, because what it does is it will evaluate in different levels of difficulty. Okay, so here we have elementary to professional level. It will test on both world knowledge and problem solving capability. So next we have Alpaca Eval. Okay, it is an automated evaluation benchmark which will have 20 annotations across NLP tasks. Okay, so it will give an idea of how robust the model is and how diverse the knowledge and the capabilities of the model is in various domains. So next we have Hugging Face Open LLM Leaderboard, which is a public competitive platform which will again evaluate the models, but it will in a competitive manner. It will have some benchmarks, it will evaluate it, and it will give some ranking in that leaderboard. Next we have GlueX, like the glue which we talked about. It is for robustness. Okay, and from bench we have talked about. So guys, if you see, almost every thing which we have talked about, every task we have talked about, the benchmark is there here. And you might ask, wasn't there is about this application at all? And if I have some specific tasks, what shall I do? So if you want to evaluate your social knowledge, go for Socket. And if you are going for some advanced reasoning, because that is where the model has failed, right? But that too in specific domains, there is ARB dataset, advanced reasoning dataset. And like I said, ethics, bias, basically to find if the model is trustworthy, then go for trust TPT. And if you're going for some multilingual ones, let's say if you're having Chinese, then you can do evaluation on CEVAL. And if you're having multiple modalities in which you need to work on, then there is this model called M3 exam. Multi-model, multilingual, and multi-level. Okay, that's what M3 is, and it will evaluate on all that. And there is this math dataset, math, apps, CUAD, all are part of Hendrix test. Okay, math is for math reasoning, and apps, if you see, it is a rigorous benchmark which will evaluate the LLM's capability to generate Python code. Possibly, guys, if you are interested, you can try to evaluate Code Llama Python with apps benchmark. Okay, then if you're having some legal documents review, you can use CUAD. And if you want to check how safety and responsible your model is, then you can use C values. And for all, I have given link here except the C values because I wasn't able to find the link for C values. Okay, so yep, that is there for specific tasks. Okay, because these shows the capabilities in underlying ways, like except maybe Helm, all are in a general way, and these will focus on some specific aspects of the model. And there are some other models as well, ANLI, which is advanced NLI, CoQA, conversational question answering, Lambada, which will check how much it will be able to handle the length context dependency, logical question answering, multi-NLI, LSWAG. There are a lot of datasets as well like this, benchmarks as well like this. Maybe you can explore all of these, and these are all if you type this name itself in Google, then you should be able to find the bench. Okay, next we have Toolbench. Okay, so like I said, lately the LLMs has been equipped with APIs or tool handling capabilities, and to evaluate that kind of model, you can use Toolbench, which has 53 commonly used API tools, and in that it will have 560 different API calls and 264 dialogue. Okay, so it basically focuses on LLM's practical application, because even the text environment which we saw, that is practical one, right? Finally, you can just use it. Maybe your creativity is the limit to connect to tools. Okay, you can, because you are the one who is building the tool, and yeah, maybe build a calculator and ask the model to call to the calculator. That is possible. Okay, so now we have seen what to evaluate and where to evaluate. Now we know the benchmarks, we know the task. Now how to build a pipeline out of it. Basically how to evaluate this. See, automatic evaluation is there and human evaluation is there. These are the two types of evaluation. Both have their own advantages and disadvantages. Okay, we'll see that now. Automatic evaluation, if you see, it is the most popular method or the protocol of evaluation because it will use metrics like ROG, blue, accuracy, F1 score, whatever we know right now. Okay, and these are the metrics which you will find in Helm as well. So that's why I said if you are going for automatic evaluation, you should consider Helm. Okay, and with NLU, mostly it will be deterministic in nature, and this kind of evaluation protocol is suffice enough. But what is the problem with automatic evaluation is it is very subjective in nature. Okay, it is very subjective. It will expect that you are generating this, but this is my label, and you should give this output. And if you are not giving, I'm not giving you any point or reward, basically. But it is not the case usually, right? You will have some. You have an objective of maybe generating a story. It might be whatever story you want. Like, let's say I'm walking in the morning, and whatever might be the story which is in the label, I can say like I was walking in the morning, I saw a dog chase me, and I ran past the dog somehow, and I hid in a house. After that I went to walk again. When I saw that the dog went, I finally saw an accident. Something like that. It can be coherent, but it will make some sense, obviously, right? It is. I've asked it to build a story, but if you see, it's just not that. Okay, you should be like this. No, the story can be however it wants, right? So that is what I said. Whenever you have some task which is not subjective in nature, automatic evaluation will fail. Case of semantic understanding task, like maybe NL. Okay, if I'm saying there is a premise and hypothesis, and if I'm asking if it is logically, if it will follow, there is only one way it should respond, right? It is either yes or no, like entitlement or contradiction. It can't say it is a contradiction, right? If it is an entitlement, it is an entitlement. So yeah, automatic evaluation will be succeeding in tasks which are subjective in nature, but mostly it is not preferable when you have generation tasks, basically. Maybe even ROG is not very good for summarization. Okay, but ROG is designated for summarization, but I've seen scenarios where ROG has failed. Okay, so you might think, wasn't then what to do? Because in what is a good evaluation section itself, we have said about it should be as much as automatic as possible and fast as possible without involving human. With some human intervention only, the pipeline should be there. Yes, if you see, LLM eval is there, which is basically using LLMs to evaluate your model. Okay, so that is a method which is possible for evaluation. Let's say like you can say like my model generated this and this was the context. Is it right or wrong? Okay, the LLM will give an evaluation and you can just overview that LLM. Okay, maybe if there is need for some prompt engineering, you can do some prompt engineering. That is where human intervention will come into the picture. Based on the evaluation it has done, you can fine tune the system or tweak around the system. Okay, so another LLM based method would be Panda LLM, where it uses a LLM system itself to basically judge and evaluate different models. Okay, it has been trained basically to evaluate the model. So that is there. But when you come into human evaluation, obviously it is far better, and it has surpassed any performance metrics which is there. And there are a lot of use cases where automatic evaluation is not suitable. For example, this open-ended generation, which I gave as an example previously, like generation of a story or something like that. Usually, if you see, it is more preferable to have human evaluation rather than evaluation from some kind of metric or model. But like I said, though it is very accurate and comprehensive or close to the real world scenario, it is very complex and costly. You can't afford to have a human, or not even one human is enough, maybe 10 humans to evaluate your model. Then it will become more costly and complex, right? So the way to go is auto human eval. Okay, so make both evaluation methods, like auto eval, human eval, and give some weightage based. Okay, so that would be the way to go when you are building an evaluation pipeline. So yeah guys, it has been a very long video. It has been 1 hour 15 minutes now, and we have seen different aspects, like how to evaluate, where to evaluate, what to evaluate, and all. And if you see, you can find the benchmark, and you can specifically evaluate of the aspects which we talked about in the what to evaluate, right? So coming on to success and failure cases of LLMs, which will be kind of a summarization for this video. Usually the generation of text is with fluency. It can generate fluent text, and it is doing very good with NLU tasks. It has good comprehension capabilities. Why I am saying this? We have said that it has been very good with open data generation, for which it will require fluency. Okay, NLU task it has performed very well, like I said, classification, sentiment analysis, and even to some extent NL. Okay, so next we have robust contextual comprehension, because if you don't have contextual comprehension capabilities, then QA won't be good. And we have said that QA is flawless. So basically, it has been giving some satisfying performance across NLP tasks, though it needs some improvement. Right. Next, coming on to failures, which is more important, guys. See, failure when you have bias and accuracy, inaccuracy while generation. There is bias and inaccuracy. Okay. There has been limited comprehending capabilities with complex reasoning and logical tasks, which we have said, right? With complexity being increased, the model has been failed. Next, we have this problem. There is no dynamic knowledge being updated. So even if you see now in ChatGPT, it will say that my knowledge is still some September date. It will say, right? So dynamic knowledge should be up. Next, we have it is being prompt sensitive with OOD prompts or adversarial prompts. It will fail. Okay, and with counterfactual task, it has performed some subpar performance. It was given some subpar performance. It seems. Let's say if I am saying like we have seen if clause in from our young age, right? If I were a bird, I would. If I am rephrasing it and saying if I weren't a bird, I wouldn't fly or something like that, right? It will fail. It won't give some good response. That is what is the success and failure cases of LLMs. And what we need to focus on is, you might think, Vasan, you're saying, okay, evaluation is there. You have told me what to evaluate. You have shown me the benchmarks in which I should focus. And let me assume that I'm also coming on to these same success and failure cases of LLM. What is the good here? And that is where evaluation comes into the picture, because you need to focus on keeping on these successes being success again, and you should work on these failures and improve the performance of the model. Maybe like if you are having bias and inaccuracy while generation, try to use some techniques like guardrails or something like that. Okay, and guys, don't worry, I'm going to make an explanation of the blog of Eugene Yan, like I said. So let me show you the blog itself right now. Just give me a minute. So if you see, this is the blog which I'll be explaining, guys. So he has also given a pretty much very big importance to evaluation. Okay, so we'll be seeing an overview of evaluation there, because in this video I've covered it in a very extensive way. I guess you would also be very exhausted by seeing this video. And if you understand that, okay, this is very exhaustive and Vasant has put some effort in it, please like the video, and it will be very appreciative towards my effort, and it will be very motivating for me. Okay, and like I said, like the video, share it with your friends, and provide your comments on this video. Okay, and these are some techniques which will be more defensive, and if you want some improvement in the performance, you can follow these methods. And don't worry, guys, this might sound very new or else like alienish to you. RAG, guardrails, what are you talking about, what is catching and all, and I'll explain it as simple as possible. Okay, there are some techniques which he has discussed, which we can use it for in this failure. But maybe for prompt sensitive, like I said, you can do some prompt engineering. For subpar performance in counterfactual task, maybe do some DPO. Okay, we have seen, right, like it will align the responses to your preferences. So maybe this can be useful here. So similarly, for every failure which you are facing, you can try to find a solution. So with that being said, I'll see you all in the next video, guys, which I said, which will be about Eugene Yan blog. And if you're wondering, Vasant, where is the surprise? And here is it. So I'm planning a playlist on LangChain. Okay, so yep, LangChain is one thing which people are asking me about. And there are some people who have said that, Vasant, I don't have GPUs, and can I do some projects with LLMs? And here will be the playlist for you guys, which is on LangChain, where I'll try to build different bots with CPU alone. I won't use GPUs, not even in Collab. I'll just build it in my local system, which is maybe a good system. I have a pretty good system, which is of i7 12 Gen. Okay, but I'll try to make sure that I build bots which will be even able to run on i5 systems. I'll try to build such bots. Okay, I hope you all have seen the Code Llama video where we have inferenced it in CPU, and in this playlist it will be mostly building it on CPU only. Okay, and I'll be building a bot. So this week it will be 3 videos. This video you'll be seeing on Monday, and the blog which I said on Eugene Yan, that will be on Wednesday, and I'll try to provide the LangChain video on Friday, most probably, or else if it is not on Friday, at the worst case, I'll provide it on the weekend. Okay, so that is the video, guys. I hope you all like this video. So I'll see you all in the next video. Until then, cheers.